Hi guys and welcome to IGCSE on Fingertips. Today I am going to take up question 4 of paper 6. Generally a lot of kids come to me with the doubts on how to crack this paper, how to write the answers for this and how to score the 7 marks. And I believe this is the easiest paper and the last 7 marks should be the easiest marks. Right? Uh, I think the whole paper you should score at least 35 plus, but this last question will make you miss your target if you don't read the question carefully or if you don't answer according to the required points. So today we'll discuss all the points we should. I think I have noted down some 10 points that we can write and therefore answer our question, right? With that, I will use some questions and solve your doubts or try to guide you how to answer those questions, right? Now, the first thing you should do is obviously read the question carefully, right? But with reading, they would have specified plan an investigation to find out what is the maximum radius of balloon before it bursts. So you've already given, you can read in the question that from the investigation I just said, they are asking you to find the radius. So your radius, the one that you are measuring, will become your dependent variable, right? The volume of air that you can fill in becomes your independent variable, right? So depending on the question, you can immediately decide what is the dependent variable, what is the independent variable. The maybe initial size of the balloon or the material of balloon can also be an independent variable or a dependent variable depending on your question, right? We'll see a few questions like that, but the first point is you should read the question, and here you can easily identify or at least circle the points that you think are important for your question. For example, few questions may have no safety precautions to be written, so you may not waste your energy in thinking about if there is any hazard or if there is any problem in the experiment itself, right? So that is the first thing. You should read your question. After you read your question, make a rough idea of the process. Okay, so let's say for example in the balloon experiment, I make a rough idea that I will add balloon with the help of a pump. I cannot measure the volume of the air that is pumped in. There is no way I can do that, right? With the pump. If I change what I am doing, if I change pump to let's say a syringe, I will take a huge syringe of 100 centimeter cube and add 100 centimeter cube of air every time I pump into the balloon. Then that can be measured, right? So it will give me an idea that the dependent and independent variable that I have taken are correct or not. So rough idea of the process. Here you will find how to change the dependent variable. Sorry, you cannot change the dependent variable. How to change the independent variable and how to measure the dependent variable, right? Because this carries 1 mark, how to change, and this will also carry 1 mark, that how do you measure this accurately, right? When we are talking about measurement, repeat, I will say this should be a point later on, but because we are already measuring, repeat 3 times at least. Okay, not everywhere. Sometimes you cannot repeat the experiment. For example, if the balloon bursts once, can I repeat it again and again? The two balloons that I find in same packet may not burst at the same volume also. So in that case, I cannot repeat. But wherever available, at least there you can write about repetition, right? And when we are talking about repetition, 5 values or 5 inputs. So you're going to do 15 experiments, right? 5 inputs, and each input has 3 output, right? And what would you do with repetition? You would repeat and average the result to make it reliable. Okay, to make it reliable. Whenever you are measuring anything, it is always beneficial to write, don't make a parallax error, or measure carefully not to make a parallax error. So now what I have done, I still have the rough idea. Okay, I have not written this down. I'm just writing a thought bubble that okay, 5 values I will measure, each value I will measure 3 times. Now, once I have found out the dependent and independent value, what I can do, I can now, when I know the process, I will go back here and write down any extra apparatus required, right? This carries 1 mark. How many ever extra required with their units? So if I say I require ammeter, so I will say within range of 0 to 5 ampere. It's not compulsory, but it's better if you do that, right? So extra apparatus required, I can recall and then say that okay, I need this thing to measure, so I will need this. Okay, I need this thing to change the value, so I need that. So you have to add it here, right? And then go back and even find out that the rough idea you had, that this should be the dependent and this should be the independent, is it correct? Go back to the question and find out. Read the question once more, now that you have the idea how to perform this experiment. Once this is done, think about the table. Okay, most of the times they ask you that okay, make a table. How do you do that? Simple. Headings, right? One should be your SR number, one should be your independent variable with its units, right, inside the box only. Then the dependent variable with its units. Okay, once you have these, and you don't need to write anything else, just SR number, the independent with its units, dependent with its units. Sometimes you have to measure more than one, or sometimes what happens is, which you should have thought of when you are writing the rough idea process, what will you keep constant, right? Generally you don't need to record that, right? But let's say I am changing the balloon, then that constant variable changes once. When I change the value, that constant variable may change again, right? Sometimes that may happen, not always. So if that is also changing, then with its unit, okay, you have to record that also. So what is the constant variable? You will get 1 marks for writing that as well. Once you have the table, generally the question is about plan and investigation. If you plan an investigation, you should be able to comment that how would you conclude this whole investigation, correct? So the last one should be, if it is a relationship between variable a and b, then you should draw a line graph. And if it is a straight line, it is related. If it is scattered, if the points are scattered, they are not related. If it's a straight line going up, they are related positively, right? Although you don't have to comment that they are positively related or not, but if they are proportional or not, right? So you can say draw, write these points on, let's say, independent always on x-axis, dependent always on y-axis. So whatever is your dependent should be on y-axis, and whatever is your independent variable should be on x-axis. Draw a line, and if, and from that line conclude the relationship. That's it, that's it, you need to write. But if it is a comparison, okay, which conducts the electricity more, or which conducts heat more, or who loses heat faster, or which is a better way, radiator, then in that case you draw a bar graph, right? And then conclude from the bar graph. Because they are discrete values, draw a bar graph. If they are continuous values, draw line graph. Line graph tells you relationship, bar graph will tell you the comparison. I hope this much is clear. Now let's find out. This is a 7 mark question. Okay, so reading and circling will not get you any mark. Rough idea process, no marks. But extra apparatus required, this is the first mark, right? What will you change? That is 1 mark. What will you measure? That is the second mark. How will you change is third mark. How will you measure is fourth mark, right? Repetition and average is fifth mark. Drawing a table is sixth mark. Telling on what axis it is, 7 mark. Then relationship establishing is, it is of 7 mark, but I'm just saying that if you forget one of them, you can still continue to write your answer. How do you conclude is the 8th mark, right? That's it. And obviously your process, depending on what experiment it is, right, your process may have extra 1 mark available for you. Okay, these are the things that you should really focus on, and hopefully you will be able to answer these questions. Now, for our understanding, I have taken a few examples. We'll solve these few examples and find out, can we find answers to this or not. Okay, a student investigates a wind turbine, which is an electric generator, okay, driven by a propeller blade. So it is a generator and it is driven by a propeller blade. Plan an experiment which will enable him to investigate how the current in resistor. So this is the resistor connected across the terminal of turbine varies with the speed of the airflow. So this is the independent variable and this becomes the dependent variable. Okay, the apparatus are a model wind turbine as shown, an electric fan to provide the moving air to turn the turbine, and a device for measuring speed. Let's say this is the device D. Okay, in your plan you should list any extra apparatus needed. Complete the wind circuit diagram. Let's complete it first. So I am attaching an ammeter, and because I want to measure the current, right, and because this is a generator, I don't need a power supply, so this is my 1 mark as it is. Okay, ammeter and directly connected. You can connect a variable resistor here to change the current. Okay, so for different resistors, if I want to measure this whole thing, then you can do that. Now it has come to my mind, but let's discuss. State the key variables to be kept constant. Explain briefly how to carry out the experiment. Include how the speed of the airflow is to be changed. Explain how to use readings to reach a conclusion. See, if you just answer these questions 1, 2, 3, 4, and 5. 5 marks you will get just here if you answer these questions correctly, right? You don't need to worry about these 5 marks at least. So what will I do? What am I thinking? I want to drive this propeller blade. Once that happens, there is some current generated which will pass through this resistor. How much ever current is passing through this resistor will be shown by the ammeter. I have a device which can measure the speed of current, right? Sorry, speed of the air passing through this propeller blade. Obviously, I have to measure it before, not after the propeller blade. I have this electric fan. Now what I need to do, I need to measure it for different speeds. So I will take this away or take this near, and then depending, I'll measure speed every time, and then I can find out that if the speed increases, what happens to the current, or if the speed decreases, what happens to the current. If I'm taking it away, then speed is decreasing, what happens to current. If I'm bringing it near, speed increases obviously, then what happens to current, right? In this, because I'm changing the position, I know I need a meter rule to measure the distance between these two things, right? Because the speed meter is already given, I need an ammeter. Is ammeter provided? No, no, it's not provided. So I'll need an ammeter. I'll need connecting wires. It's always safe to write, I'll need connecting wires to connect all of this, right? What else do I need? I don't know, but let's plan the experiment. What I'll do, I'll measure. Now when you plan this, even roughly, you have to meaning roughly, meaning don't write it down, but actually imagine you yourself doing this. So I will measure the distance. Let the distance be 2 meters. Then I will measure the wind speed, which is the independent variable. Okay, so I will measure the wind speed. I'll find out this is the wind speed. Then I will let the propeller blade rotate, or I'll keep on rotating it, and then I will record the uh, current. Where will I do all of this? I will obviously make a table, right? So this is SR number, you have wind speed, you have distance, and you have current, right? Wind speed should be in meters per second, I believe. Distance should be in meter, and current should be in ampere. So I can measure all of these three things, but I am finding the relationship between these two. I'm not concerned about distance. Why am I changing distance? I am changing distance so as to change my wind speed. This is one set of values. Now, what can I do? If I had connected a variable resistor here, I could increase the resistance. When resistance increases, the resistance, oh, acha, I want to, okay, so we'll not do that. We can change this resistor and we can have 5 such values, right? I would suggest measure it thrice for each value and measure 5 such values to establish a proper relationship. Okay, so I can measure 5 such values, or because you are already changing the wind speed in this particular experiment, you don't need to measure it 5 times. You can measure it for 5 different speed. So what I'll write, I independent variable is the distance of the electric fan from the propeller blade, or the speed of the air passing through the propeller blade. I will change the speed of the air by increasing or decreasing the distance of the fan, right? So dependent variable, or the variable to be measured as an output, is the current. What I'll do now, so how many marks have I already gained? I have already stated what I measure. I've already stated both the things that I measure. I've already stated how do I do that, right? Then 1 mark is for how do I change this, right? Decreasing or increasing the distance. Please don't write changing the distance. है ना? Don't write ambiguous statements. Exactly write how you are going to perform this. है ना? If I tell you write the answer, that is not how I instruct you to do it. I have to be specific. So in your answer also, you have to be specific. Change the distance, increase the distance so that the wind speed will decrease. Measure the current. Do this thrice for each distance and measure current for 5 different distance with an increasing value of 30 centimeter or 40 centimeter or 1 meter. But what might happen here, see, if I take it too far away, maybe the propeller blade will not rotate. So don't keep your distance too much, right, in these type of questions. Then make a table of all of these things, and on the x-axis plot the wind speed, on the y-axis plot the current, draw a line graph and conclude from the shape of the line, right? You've not, but you should say that you will take an average of the current and the wind speed, repeat experiment thrice, right? I already said this, repeat the experiment thrice for each distance and measure for 5 different distances, right? So have I listed the apparatus needed? Yes. Have I completed the wind turbine circuit diagram? Yes. Have I stated the key variables to be kept constant? Keep the resistance constant for this whole cycle, right? So that is yes. Explain briefly how to carry out the experiment, including how the speed of air flow is to be changed. Yes, I have. I am taking this away. Or there may be a regulator here. You can change the airspeed then also, but it's not given, so I've assumed that it can't be changed. Explain how these readings, how to use these readings to reach a conclusion. So how would you do that? Make a table, make a graph, and reach the conclusion. Okay, I believe this should give you the full marks required for this question, right? Then let's see, is there another question? A student is investigating the factors that affect the size of the crater a ball makes when it is dropped into a sand. Okay, so this is my dependent variable, dropped into a sand. This is my independent variable, right? Plan an experiment enable you to investigate one factor which might affect the size of the crater. You have metal balls of different sizes and a tray of sand. Write a plan for the experiment. In your plan, you should state which factor is to be investigated. So 1 mark, key variables control, meaning keep constant. Additional apparatus needed, Okay, briefly, how would you carry out the experiment? What to be measured? Okay, state precautions to obtain reliable results. So repeat. Suggest a suitable graph which could be drawn from the result, 6 mark. You may draw a diagram if it helps you to explain your plan. But this is not, see, if you write proper steps, then this is already marked, right? So what will I do? Let's think about it. See, I'll take one ball and drop it from a constant height, right? Then take another ball, drop it from the same height. Take another larger or smaller ball, take it and drop it from the same height. Or I can take one ball and drop it from different heights. I want to investigate the size of the crater when a ball is dropped into the sand. It is not saying that does it matter which size of the ball or the height from where ball is dropped. So I am going to take height, even if it says metal balls of different sizes, right? I need only one of them. So what is my experiment? First, define the dependent independent. So your independent variable is the size of the ball. The dependent variable is the size of the crater. How will you measure the size of the ball? You can measure it with vernier calipers. How can you measure the size of the crater? You can use it by drawing a meter rule. Okay, sorry, you can find it out by using a meter rule because you don't require that much accuracy. You're going to repeat it. Okay, a tray of sand, right? Now, state which factor is being investigated. The size of the crater is being investigated. I would keep the size of the ball constant, but I will keep on changing the height. So here independent variable is the height of the ball from where it is dropped, because I changed that, right? So list any additional apparatus needed. Do I need another apparatus? Yes. Meter rule is not given. Vernier caliper is not given. I need meter rule to even change the height of the ball. है ना? So how would you carry out the experiment? Okay. So I will now carry out the experiment. I'll take a ball and then I will place it at 1 meter height. I will then keep the tray of the mud below it, and it should be flat, right? I want to measure the size of the crater there. Now it should be flat. So I'll make the sand flat, drop the ball. Carefully remove the ball and measure the size of the crater. How will I measure it? I'll keep a ruler on top of it. From exactly top, I'll measure the end points and then calculate the size of the crater. Once I have done that, I will make the sand flat again. Again at 1 meter, I'll drop the ball. Again, I will repeat the whole process. I will do this for 1 meter 3 times. Then I will go to 1.2 meter. Repeat 3 times. Go to 1.4 meter. Repeat 3 times. Go to 1.6 meter. Repeat 3 times. Because I have started at 1 meter, I have to go till 2 meter, right? I have already said that you have to repeat this at least 5 times. So three repetition for same value and for 5 different set of values, right? Then state the precautions which should be taken. So I should again make it flat again always. Otherwise, previously there was a crater, and if I drop a ball again, the crater might be larger because the sand is loose there, or there is already a crater. Don't measure the depth of the crater here, it becomes difficult, right? It just came to my mind that you can measure the depth of crater as well. You should be measuring the width of the crater. Okay. Then so the sand should be made flat again after every experiment. That is a precaution I will take to obtain reliable result. I will do this experiment thrice for each value and average the results again to increase reliability. Suggest a suitable graph which could be drawn. So what can I do? I will make a table in which it is height from where it is dropped and the size of the crater. The size of the crater in centimeter, the height from where it is dropped can be in centimeter. Then draw a graph, draw a line graph and find out the conclusion. If suggest a suitable graph which could be drawn. So they are not asking you to conclude it. They are asking you which graph should I draw. You should draw a line graph because you are trying to find out the relationship between two things, right? You may draw a diagram if it helps you to explain your plan. Now I have not drawn the diagram, but I believe we have covered everything there is to, if you just read the question carefully and decide all the factors that I have stated. I believe that this is not the last one. Okay, this is the last question that we are going to study today. A student investigates the time taken for water to evaporate to dryness, right? Evaporate to dryness, very important here. When heated from above, the power of heater is constant. Following also available: supply of water at room temperature, meter ruler. What will meter ruler help me do? Decide the height above which, above the shallow dish, the heater must be placed. Plan an experiment to investigate how one factor, what is the one factor? I can say the temperature of the surrounding or the distance of the heater from water, affects the time taken for water to evaporate. You do not need to write about safety precautions. Okay, state any additional apparatus if you need to measure time, right? You've been given meter rule, but you need to measure how much time does it take to evaporate to dryness. I need to measure time, so I need a stopwatch, है ना? Then explain briefly how would you investigate, how would you do the investigation. Okay, so how would I do this investigation? I'll place this at some, let's say 50 centimeter above the base of the plate. Fill the plate, I'll make a marking to half of the height, right? I'll make a marking half of the height and fill it to half. Place it below it exactly at the center, not exactly, approximately at the center, because then if you say exactly, you have to say how exactly. How will you keep it exactly? So say approximately, keep it at the center, and let the water evaporate to dryness. Turn on the stopwatch as soon as you turn on the infrared heater. Repeat this 3 times for every height, and repeat the experiment for 5 different heights with an incremental of 10 centimeter or 20 centimeter or 1 meter, whatever you want, right? State the key variables you would keep constant. This should be stated at the start of the experiment. See, power of the heater is already constant. I'll keep the initial temperature of the water constant. I will keep the volume of the water constant. I've marked it to half, right? So I've kept the volume of the water constant. I've kept the placing of the dish constant. For every distances, I've kept the placing of this shallow dish constant. Draw table or tables with column headings. So what will I draw? So I have distance of the heater from the base of the shallow dish in meters, time taken for the water to evaporate completely to dryness in seconds. Okay, explain how would you reach your reading to, sorry, how would you use your reading to reach a conclusion. You would draw a graph. On x-axis you would measure, you would keep the distance. On y-axis you would take the time taken by all of this to happen. Now let's find out if our marks are done. State any apparatus required. Yes, okay. Stopwatch. How would you do the investigation? What to keep constant I have stated, what to not keep constant I have stated. So everything is stated here. Okay, doing whole thing is draw table or tables is done. How would you use your readings is also done. Is there any precaution you need to take? You do not need to write safety precaution, but see, I think that because they have stated that you have to investigate just one factor, another factor that I believe can interfere in this is if you do this experiment outside a room, then there will be air flowing, right? And that is a factor that can change the rate of evaporation. This surface area can also change the rate of evaporation, but because we have kept the shallow dish constant, it will not now affect. But air can, right? If the air wind velocity is there, if it is high, it can change the rate of evaporation. So what I'll say, perform this experiment in a closed room so that there is no wind to alter the rate of evaporation. I think that is one thing, because only one factor needs to be investigated. That is one thing you need to add here. Other than that, I believe we have scored all the 7 marks there is to score here. Hopefully this will help you with your doubts in this question. If you have doubts in any other question, if you want to ask any other subjects, please let me know in the comment box below. I'll see you in the next video. Bye bye.